Hello everyone. Today we're going to look at reading graphs and how to find the period, amplitude, frequency, and shifts of a function, our trig functions, notably sine and cos, from their graphs. And first, to get started, let's do a recap of what all these keywords are. So, the period. The period of a function tells us how many times it repeats in an interval. So our interval is usually 360 degrees. So our period will tell us how many times our function repeats in 360 degrees. Or a function with a period of 360 repeats once every 360 degrees is what a period is. Now, amplitude. Amplitude tells us how high the hills are, or how far a function deviates from the mean. So our amplitude is this distance here. Frequency. Our frequency tells us how many times a function will repeat. A frequency is just 1 over period. Now, shifts. Shifts are generally the trickiest ones out of all of these. A left or right shift will tell us that our original function has either moved to the left or to the right, such as this. And a vertical shift will tell us if our original function has moved up or down. Okay, let's try some examples now. This is a trig function, that is, it's either sine x or cos x. Find an equation of the type y is equal to a sine x or cos x plus b plus c to express this graph. Okay, a, here is our amplitude. B gives us our left and right shift. C gives us our vertical shift. Now, looking at our graph, we know that normal sine and cos functions have an amplitude of 1. This graph, we see that a is equal to 2. Maybe that's not perfectly clear. Alright, there. A is equal to 2. Now, remember, if we shift the sine function forwards or backwards, we can turn it into the cos function. So it doesn't actually matter whether we choose sine or cos here. So let's choose sine, because this function starts growing at x is equal to 0. So we can approximate it using the sine function, or it is the sine function, and we don't have to shift it as much. So a is 2, b is 0, because we're using the sine function, and we're not shifting it either left or right, because it's already in the right spot. And let's find c. C is the vertical shift. Sine usually starts at 0. Our function starts at 1. So it's vertically shifted upwards by 1. So our total equation is y is equal to 2 sine x plus 1. Now, we see that the period of this function is going to be 360. That's the time it'll take for one full oscillation. So the frequency will be 1 over 360. If the period wasn't 360, we would have had to change our function around a little bit. It would have looked something like this. A sine x plus b over d plus c, where d is the period over 360. So we might try one of these in the harder examples. Okay, next example. Now, you're given that your function y is equal to a sine x plus b plus c. Try finding a, b, and c. Okay, let's do it now. Let's find a first. A is usually the easiest. The amplitude is 0.5, so a is 0.5. I usually find c is the next easiest. This function appears to be centered around y is equal to 0, so it doesn't appear to be vertically shifted at all. So we must have c is equal to 0. Now, let's find b. B is the left and right shift. Now we're told this is a sine function, but it looks just like the cos functions we know. So, how do we turn a cosine function into a sine function? Well, if our sine function looks like this, and our cosine function looks like this, our cosine function is just our sine function moved backwards. And backwards by how much? Well, sine over here, if this is 90, and this is 0, sine has to move this point on the sine x has to move to this point on cosine of x. So, every point on sine x has to move 90 degrees to the left. How do we express that? We say cosine x is equal to sine x plus 90. So b is 90. Now, for example, what was originally sine 0 will now take the value of sine 90. So, this is sine x plus 90 is equivalent to moving your entire sine function to the left by 90 degrees. Sine 0 will take sine of 90, sine negative 1 will take sine of 81, and so on. So y is equal to 0.5 sine x plus 90. Cool.